mathematical answer. There's a website, Wolfram Alpha. If you Google Wolfram Alpha, you can go here. You can type in any question you want, such as how many penguins equals a whale. Insufficient. So I didn't phrase it well enough. So you can ask it any math. So let's talk about mathematical questions we've been talking about. How many degrees in a triangle? But, so it's not just your standard Google results. It is every related mathematical result that might pertain to your question. So this is where you can like deep and accurate Google search for things. So David, I love that you brought up that like Google couldn't even solve it. Well, you have a page full of information all about me asking the question, how many degrees are in a triangle? Wolfram Alpha. If you just search Wolfram Alpha, you will get here. And it's actually wolframalpha.com.
Wait, so my question was that one of the questions asked how to tell if the angle is greater, equal to, or less than 45, and I did not know, and it did not help.
Yes, hang on for just a second. So hold up. Let's go one question at a time. One question at a time. 78. Everybody pull out your homework from last night.
Were we ever taught that?
So remember, this homework is review preview. So we are looking. Maybe switch tabs. We're looking to challenge ourselves, right, David? So some of these questions will be things that you're not yet comfortable with. So this statement is going to sound wrong. Try to be comfortable with being uncomfortable. Right? So how CPM is going to push you is towards that level of extending yourself and not just applying what you know.
If I'm comfortable being uncomfortable, then am I uncomfortable?
I don't know. That's for you to decide.
Then I can never be.
All right, any questions on 78? C and D are both no's. A and B are both yeses.
Oh, yeah.
Oh, wait, this is the answers?
Yes, this is just the answer.
Oh,
I can show you the questions again if you want. But
I only did part of it.
so remember, it's about the process. I don't know who left.
I did up to 83.
It's just a water bottle sweat.
Oh.
It's condensation. All right, moving on from 78. 79 are area rectangles.
Yeah.
So you were figuring out the binomials that were the dimensions for that rectangle, all squared away there. See what I did? All squared away.
Okay, that's great.
80 asked you for the converses that we discussed yesterday in class. Can anyone remind us how we make a converse?
Don't you like switch the if and the then?
You flip the if and the then.
And if it's still true, then the converse is true.
Well, so remember what we're looking at is eventually we're going to look at the converse, the inverse, and the contrapositive. If
Okay.
all three of those are true, it's a really solid definition. So,
Are we gonna use like actual definitions? Okay.
so like a square is a rectangle with congruent sides, right? A rectangle with congruent sides is a square, converse, right? But if a rectangle does not have congruent sides, then it is not a square. Or if a shape is not a square, then it is not a rectangle with congruent sides. Those are your four different iterations of the statement. We'll get there. All right, 81. Oh, I'll turn that on. Sorry, I was warm after the first class. And this is in our laser zone anyways. All right, 81, you had to use your Pythagorean theorem to derive that height in that trapezoid. So remember, and I think most of us are pretty, I hate that it always makes it big. Most of us are pretty solid on this, but the trapezoid bases are those parallel sides, so the 12 and the 18. Now this 5 gets added on, right, because the 18 was down here, so the base was actually 23. So then your height from the Pythagorean theorem comes out to be 12, and your area is 210 square feet. Questions? 82 order is very important. That's the biggest thing with 82. So if you follow their clever RIGHT, right, if we put them in the right order, but then this is not very nice. Does it make sense? Like if you started with GHTRI, then you'd start with LAFES. Right, so follow the order. Right, that is not very. I have too many tabs open.
How'd you find the area?
What do you mean, for the trapezoid?
For 83.
There's a pentagon.
Yeah.
I didn't know how to find the area.
Ooh,
No,
we will
I
talk
know what to
more.
do. I know what to do.
You want to talk it through?
I split it into two shapes. Oh, that's what I did at least. Did I even get it right? Can you tell me the answer first? Did I even get it right? I need to first.
208. 52 and 208.
Oh my god, I did it right. Okay. So I split it into a triangle and a rectangle, and then I found the height of the triangle, did the area for the triangle, and did the area for the rectangle, add them together.
So essentially what you're saying is you viewed it as a composite shape. Right? When we plot these 5 points, when we plot those 5 points, it's not a shape that we have a nice formula with. Right? It's not like wham bang plug things in and just put it in your calculator. You got to actually cut the shape apart, and you can do it a few different ways. Once we get to hexagons, we can cut it straight down the middle and make 2 trapezoids, or with any regular polygon. What's the trick we can use with any regular, all congruent triangles, right? Because a regular polygon has congruent triangles. So if you can recognize the polygon's regular, we know we can use triangles. So that's going to be a strategy we use a lot this year, especially as we get into trigonometry. And we'll need to use those central angles to help us with that. 84. Not similar. Angle, and then side.
Oh, I got that.
Did we get to these, or should we come back to checking answers?
I didn't, but like
I want to get to 288.
I can explain it to him.
You got all the way to 288.
No, I finished except 288
I
where I was like, five.
Yep, I will scroll us down to there.
I
See, look. Okay. So if this is like small, right? But if we make this side longer, the angle gets bigger. So like look.
What theorem is that? We talked about it.
Wait, what?
It's the long angle.
It starts with an H.
I'm so confused. Hold
The
on.
hypotenuse?
Wait, I thought the angle doesn't change no matter how long
No,
the
the
side
opposite
is.
side. Depends. The opposite side.
What?
Because like look, if like this side gets longer, it doesn't matter. But if the other side, like this side right here, gets longer, then it makes this angle get longer. It depends.
Does no one remember the name of this theorem? It's okay, but we
No,
talked about
only
it.
one of them changes it. That's only
Like when I
one
open the door further,
Oh! Hinge theorem.
the hinge theorem,
Oh, I forgot
Right?
about that.
the opening of the doorway, if that opening gets bigger, the angle has to get bigger.
Yeah.
Or if the angle has gotten bigger, the opening has to have gotten bigger, unless one of the other sides has changed. But with the hinge theorem, we're saying that the door can't change lengths.
So how do you put that in
Here,
there?
let me explain.
Because when I looked at the homework,
So
I was
look,
like, didn't
So see, this is 3 and
Listen to
4
that.
is bigger. 4 is bigger.
4 is
so,
bigger.
so this angle must be bigger than that one since it's longer.
Even though it doesn't look like that in the drawing.
Because this is 90, so like these two have to be 90 together.
Yeah.
So basically, if it's like more or less, I don't like. So like this side and that side, they're like pairs. So if this side is longer than that side, so like if this is like here, I don't know, but like if it's longer, see, it gets bigger. So
Do you want to tag me in, Leon?
yes, I can't explain.
By the way, you're very close to the mirrors and like.
Ooh, be careful with the mirrors.
So
You'll mess up all the lasers.
You will be sacrificed if you mess up the mirror.
Alright, so
Someone explain for me.
David, when we
Kind
look
of get it.
at angles and triangles, I have left all my pens elsewhere.
Normally they're up there.
Mirrors are like.
I don't know where one of them is. When we look at angles and triangles, let's start with B to just have a nice reference
Oh
point.
yeah, because they're both 18.
David, what do we know about B?
It's a right triangle.
It's a right triangle. Keep going. know that the hypotenuse is across from the 90
Yeah.
because actually remember, hypotenuse, what does hypo mean? What's hypo mean? Think back to last year.
Height is same.
Hypo, hypothermia, hypo.
Cold.
Close.
Long.
Hypothermia. Extreme. Something.
Low.
Deprived. Don't know.
Top.
The reason that is the hypotenuse, you're getting closer,
Deprived.
is how it relates to the 90-degree angle.
Wait.
It's like that.
How does hypothermia relate to
bottom
angles?
side.
I don't get it.
Below. Hypo means below. Hypothermia, you're below the temperature you want to be at. The hypotenuse is below the 90-degree angle. So, we don't really need that though, because the question is asking us, and I'm coming to you, Sammy. The question is asking us, when we look at these angles, this angle versus this angle, how do the sizes compare? Because we know they're going to add up to 90 because it's in a right triangle. So they just asked us more than 45 or less than 45.
So how do we figure that out?
Sammy, here, what do we know?
Because they're both 18, wouldn't that make it kind of like a right isosceles triangle?
Because they're both 18,
So then wouldn't they be the same?
we can mark out that the legs are the
Because
same.
isosceles triangles have equal angles on them.
Yeah.
Okay.
So that's how we deal with B. Right, but then if we relate back to the hinge theorem,
That homework help did not help me then. It
It
told me
did.
something
It helped me.
way different.
Well, I looked at the answer for C and then I was like, wait, why does that?
when
Then I
we
realized.
have a right triangle, the legs both share a relationship with the hypotenuse, right? Because each leg is connected to the hypotenuse. The size of the angle is directly related to the length of the leg opposite it. So we also create like a Y up here. We would say Y is directly related to the size of that leg. Well, because the 4 is a larger leg, it's going to open a bigger opening. So imagine a door open 4 versus a door open 3.
Okay.
Right? So our hinge theorem tells us the door open 3 versus the door open 4. Yeah, the 3 is going to be the smaller angle than the 4. So the door that is opening, right, the size of the opening is 3. This will be less than 45.
Wait, but because okay, got it.
And then this will be greater than.
So I
Yeah.
should put this into
45.
words. Right.
Goes back to our hinge
I
theorem.
think I get this.
So if you want to write down the hinge theorem in the simplest way possible, the size of the opening determines the size of the angle.
Are we writing this for our notes?
You don't have to formalize it yet. We don't have to have it memorized, but David said he wanted to write it down.
The
So
size
if
of the opening.
the size of the opening determines the size of the angle.
You know, I searched this up on Google, like what to do when you know two sides and one angle, and it's not helpful.
Now, if you search hinge theorem,
It
you can
would've-
find some really useful information there.
I forgot that existed.
Wait, so the size of the opening.
Okay, let's shoot some lasers now.
Determines the size of the angle. But so really what we're saying, remember what we're actually looking at. If you want to use different terminology, the leg
Because
relates
A is
to
greater
the
than
opposite
2 is
angle.
greater.
The leg relates to the opposite angle.
Oh my god.
So a leg of 2 versus this unknown, and actually we can call that theta since it's an unknown angle.
Theta?
Leg of 2 versus like, yeah, so
Like
our
alpha,
Greek
beta,
symbol,
gamma, delta, epsilon,
we haven't used this much yet this year. I call it the Easter egg. But that is our Greek symbol theta. It is what we often use for unknown angle measures. So instead of using x, very soon you will start to see the symbol theta incorporated. We use more Greek as we get deeper into math because x gets overused. Yeah, x is overused. All right, any other questions on this homework? We will come back to these because I know it was a big assignment. We're going to play with lasers.
Yay!
All right, so everyone have the homework written down? Are we all good?
No.
No? I know, we moved on quickly. So, a little rogue from the lesson, which, big surprise there. Our lesson is all application of similar triangles, right? Also, big surprise there because that's what we've been working on. But we're already pretty good at that. So, I thought I'd move us forward, and this is actually getting a little bit ahead of ourselves, but I think we're ready for it.
What?
In the real application, we're going to go back to the book and answer a few of those questions. But how could we determine where this laser is going to hit across the room?
Angles?
Yeah, the angle.
So, now without being able to get up and do anything, I want
Okay.
you to discuss with each other, and you're all kind of spread out, so we can kind of just have a class discussion. How are we going to be able to say when this lines up where it's supposed to and hits the mirror,
Oh, I see what
right?
you
Ah, you
mean.
see what I did here.
Oh, that's great.
When this lines up with the mirror, where will it hit the opposite wall?
Oh,
So
like
what
the
sort of things, let's decide as a group what we would
Oh,
need
I know.
in
Figured
order
it
to
out.
do this. So, Leanne, give
Okay,
me
so
one.
I think I got something else.
What?
It's gonna be if the mirror is flat, it's gonna be perpendicular to the slope of the new laser will be
Perpendicular?
Yeah, because it's
Okay.
Well, because they
Now, do we-
intersect at
Yeah.
where the mirror is.
Yeah.
I agree, but with with what we've been talking about, perpendicular. Are we sure? So if I hit at a 30-degree angle, you're not allowed to measure anything yet, right? We're deciding what we need.
Oh wait, no, I don't. No,
So you're defining things that we may or may not know, but I'm asking, what do we need? Right? Can you give me something that we would need? Like if I ask you guys to do this task, you're gonna say, well, first we need to. What are those things?
If the laser hit that mirror, it would.
Could you get like a
Mirror and
protractor
over there.
and see like the angle that
Wait.
maybe?
Yeah.
So what are the
Do
basic?
we need that?
What are the
This is
basic-
what I'm asking you guys. What do we need?
Measuring stick.
So we asked, do we need a protractor? So I'm going to start writing these things down because these are. Do we need a protractor?
I'd say
So
like
like a meter stick or something.
Yeah, some sort of measurement tool.
so like those yellow things in there.
Oh, look, yardsticks, measuring stuff. Interesting.
Oh, wow.
What else?
I wonder why not.
A calculator.
Calculator.
Probably.
That's your brain. Come on. Okay.
No, I'm not gonna do division.
I'm not gonna do division today.
What are you going to use this measurement tool to do?
To measure
What things, though?
the
To see how far like the things are apart.
To see how far the mirror is from the wall.
Okay, so let's draw a little picture. So on your paper, let's write lasers.
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 obviously.
So if we label the laser point L, let's go ahead and label this F for floor, maybe. And over here, what would we label this point then?
M, mirror.
Ooh, now I agree. There are actually two mirrors up here.
Oh, M
Mirror one,
M
mirror
Ooh.
two.
So I've actually got them labeled A and B.
Oh.
So if you want, because I have written on the mirrors labels A and B. So we have mirrors A and B. And the reason I give you two different mirrors is to push you guys.
What do you mean?
Now, some distance across from here, we have, I'm going to call it point C for where the wall and the chalkboard and that vertical line comes down. And what we're trying to figure out is this. And we might as well call some point T sub A and T sub B.
Wait, this has
Oh,
to be
right,
the
for when the mirror, when it hits the
Mm.
mirror,
Yeah, it has
and
to
when
be
it
the
hits mirror B.
The angle of like the laser hitting the mirror like depends on the distance.
So let's say there's a terminal point, right? Our terminating point.
It's where it can go anywhere.
And we need to find T sub A for the terminating point of A, and T sub B for the terminating point of B. But I'm not quite sure which one's going to be higher up or lower, so I'm just going to kind of put.
I feel like A would be higher up because
Yeah, because the
it
slope
hits
is
sooner, so
the
it
slope
go.
is steeper.
So it'd have more time to
So
go
so
up.
make
I'm going to do nothing
No.
You
for the
always
next
say
5 minutes, but I want you two to take charge of the conversation because Sophia and Athena have just been riding in the back seat. So what do you think we should start
Staring
with?
out the back window.
So for the so we should measure the way that like the laser would hit, like what angle it would hit it at, and since it since it would reflect, the angle would be like the same back and forth. So we'd have to measure just to see how far it would.
Okay.
I think I figured it out.
Now, what's interesting is where you're talking is actually in trigonometry land. Like what you're saying is dealing with trigonometry, which I love. But what if I tell you you can't turn the laser on? You're not allowed to work the laser.
I know.
Athena, what do you think?
No.
I'm gonna come back to you, Sophia.
Me?
Athena, what do you think?
I figured it out already.
What do you think, Athena?
No, I think it is. I don't see how
I think nothing.
You think nothing? I doubt that.
No, Athena probably already has the answer. She just wants to watch us suffer for a bit more.
Athena, what would you collect first? If somebody said, okay, you go do something, would you? So Sophia said, get a protractor, try to get the angle, but now I told her she can't turn the laser on. So what would you do first? Aside from tell the angle, take some deep breaths.
Obey the rules and turn the laser on and then
I already know I know the answer. Can I
Guess
say
what,
it?
Leah? You're always telling us we're too ahead for you, but clearly you were lying.
Leanne's dying.
I figured it out, kind of.
Like when you want to
Turns out you
spoil
were all
a
wrong.
book to someone.
Yeah, watch me be completely wrong and I have no idea what I'm talking about.
All right, I'm out. You guys are on. See if you can figure it out.
Okay.
Wait,
So-
can we turn it on?
Wait, can I?
No, you cannot turn the laser on.
Can
Yeah.
I use this number to show?
Sure.
Okay, I
Don't
think
touch
that
the mirror.
Watch the
this,
mirrors.
the slope over here will be the same because it's flat, so it'd be like the same slope over here. But like that's like so it'd be at the same point here if it was the same distance.
So they
So
are.
if it was like FA times 2, which is like over here, then it would be the same as that
Explain.
up there.
Okay,
So, like,
I kind of get
can I
what you're
draw?
saying.
Oh yeah. Yeah,
Okay,
dude.
so,
The
like,
pen's up
this,
there.
If it's flat, so like it'd be like that.
It'd be kind of like
Yeah,
a triangle with
So
like the
this
same.
distance was the same as like another F. So if you like reflect F across this line, and it's like over here, so like we have an F prime here, then it would be like that.
Okay, I
So
kind
it'd
of.
be the same. It'd be the same point.
Wait.
Because the mirror, since the mirror is flat, it would like.
Yeah, it'd be like the same slope.
So you have to find the distance over here, and then multiply it like.
Wait,
over there.
so if it was the same
What are we even
distance,
trying to
wouldn't
figure
it kind of
out?
make like
Where the
an
laser hits the wall.
But
What if it's
that's the wall. Hit the wall.
If
Wait, hold up. Wait, so where the laser hits the wall for A mirror and where the laser hits the wall for B mirror?
Yeah.
We need to
So
find a
this-
terminal.
So this will keep going.
Okay.
So it'd be like at this point. So we have to find the slope for.
But if the laser and the wall were the same distance from the mirror, wouldn't it be like the same distance?
No, we can
Like
find
the
that.
same.
Are they the same distance?
They're not, but if they were, wouldn't it make like
Can you move the mirror?
No.
No.
no?
Wait, but what we could do is
Measure.
so you measure to see how far that is from the ground,
Okay, but
and then
here, let me
over to
explain.
the
Point of getting a fancy laser
So
and
these
turn it on.
be the same thing. It's like that. Yeah.
What the
Yeah.
heck?
But so you measure like so you could see like if you measured from the laser to the floor and then from
So why don't you go ahead and do that?
I need to make.
There's measuring tapes up there.
okay.
If 5-year-old me ever saw this,
You
he'd like
know,
freak out.
Mess with measure.
But he'd be happy because he saw lasers.
So hey, Sophia said that she wants to take a measurement from the laser down to the floor. So that's LF, right?
Can we measure?
Wait, we can make a
Yeah, you
fake
can measure. The
laser
only thing you
thing.
cannot do is move the mirrors or turn on the laser.
No, we can take Pythagorean theorem by doing this.
Oh.
and that.
Wait, we don't.
Wow,
no,
we
no,
are
no, we
smart.
Now realize, even if this pivots, the move that the laser takes is very, very minimal, right? So the point, yeah, just look at how high tech it is. So it's about there is where the laser is going to shoot out of. So you guys collect whatever data you want.
Yeah, we don't need to know what the hypotenuse is because
Yeah, we need to know the slope, right?
yeah, we need to know the slope, and then if we go
Yeah, this feels
Okay,
like
wait,
math
first we
camp.
have to know this.
This feels like
Yeah.
science class. We're trying to
Where
figure
is
out
the
that
point that
mystery.
it's down? Here, get here.
Except it's math.
I'm gonna need at least like 3 here.
When you drop a straight line down, what's that called?
It's the vertical.
Starts with an A.
The angle.
Altitude. When you drop a straight line down, it's the altitude.
Yeah.
believe in you guys. Do you want to measure it in inches than
Wait,
millimeters?
what is the exact rate right here?
Do you want to do inches than millimeters, Lorraine? Let's do centimeters.
Okay, that's
Or whatever.
Those measuring tapes have the metric markings on them also.
Where are the measuring
Yeah,
tapes?
just use the measuring tape.
Yellow container.
I am blind.
Did you ever do this last year?
This is what we need.
Yes.
Oh, God.
Probably one of the lessons.
Wait, this is part of the lesson?
So make it. No, you.
Did you move the mirror?
No.
Oh, wait. That is a high tech.
I found a pen.
Oh, sweet. Where was that? Oh, well, I don't think that's the one that I'm missing.
Might be.
Is that helping?
I like it.
Okay, and now lock it.
Lock it. Click the lock.
Just so you know, I'm shooting for the center of the square. That's why the square is on the mirror. You're shooting for the center of the square. That's what I
There,
always do.
now it's locked.
No.
No, it is not. Push it up hard then. Is it locked? No, it is not. I think your thing is broken.
I literally just asked Mr. Flynn if I could have some new measuring tapes.
Yeah.
So, we will work on it.
Wait,
We will
someone
work on it. Here, I'll try and.
How long is that way measure? Measure with the center. The middle of the center. Where's the middle?
This one locks. You have to push it all the way down.
David, it's a mirror. What do you expect?
Okay, wait. Where's the middle? It's about 5 feet. 5 feet.
5 feet. Yeah. 5.
You could write down both measurements.
No, just wait, like. No.
Someone write this info.
5 feet to 6'1".
What is that? Here, I'll write it down for you guys. What is that? What is it?
6.5-ish.
Well, what leg? That's FA, right?
Wait, no, 60.
What is FA?
60.5.
60.5
Floor
inches.
to mirror equals 60.5 inches.
Or,
153 centimeters.
okay, keep going.
So now they have to do floor.
Do you have this one?
You need to do floor to wall, right?
What's that left?
So,
Wait, no, get.
wait, no. We need from A to the wall.
Where's the other measuring?
So, this one.
I don't like it. Don't touch the mirror. I will touch it.
So this one, we do up to where like the mirror points. So like right there.
Oh, I just killed it.
Okay, so let's go back here to where it was. Here, so hold that down, David. David, can you hold this down?
Yeah.
31 and a half kids. 31.
And then what is that metric?
Wait, you're still recording us?
Yeah, of course.
That
This is the best part of class.
That's like
No, wait,
79.
Mr. Hudson,
79.
yesterday we saw you post that video and Athena was your first view.
Nice. Like and subscribe.
Like and subscribe to my YouTube channel. Share
Wait, no, it's still.
Now, one thing that's going to frustrate you is when you get over here, getting to the wall
Oh,
is
yeah.
rather annoying. However, what you could do is just get to the leg of the table and then measure that distance. Composite distances. Composite distances.
No, you measure that.
I'll measure this.
No. Don't mess that face.
That
Is that helping?
I'm helping. Athena isn't.
That's like.
Guys, I think if the math 8 people came in here, they wouldn't say Mr. Hudson is lame anymore.
We have 13 minutes.
Oh.
What is that AC?
1
Was that you guys added up?
Plus 26 and a half.
Well, what is that? 26? 1.
Inches or centimeters? Inches.
What's 112 plus 26? And what was the decimal? You know, we could also use Google to convert these values. You don't want to measure both? So we could do that.
Right, the rise.
Oh.
So 351.79.
The land, the height thing is like, height is 28.
Wait, are you
Wait, no,
sure?
it's like, we need a rule,
Do we know AB or BC
No, I already
or
did the
FB?
height.
What's the height?
It's on
Wait,
the
we
board.
don't know
31
AB,
inches
you guys.
or
Okay, so we do 31 over that.
Guys, someone measure AB.
Wait, what's 31 over? Okay, get me
Calculator. Oh god. From which end though? Wait, from which side?
So it's 30. Yeah. Alright, so the
Can we just do like all classes like this?
Oh, from the
yeah,
middle.
I like this. Covering it. 31 divided by.
No!
These are inches.
Wait, what's?
Mr.
These are
Glenn,
also
the
inches.
PTA needs new rulers too.
No.
Give me one that's not good.
Okay, so it's that number.
I heard that.
Can we put it on the computer?
Yeah, just write 0.51.
It's like 37.
It's about 0.
Sure.
Something in.
Yeah.
Roughly 0.51.
0.5.
Mr. Hudson, 36 and a half.
For AB,
For AB, it's 36 and a half.
should have been
No, just
36.
write 0.1.
You're good. It probably is 36 and a half now, but I tried to set it up 3 feet apart.
Like that?
Yeah.
Inches?
We moved
No,
it.
that's
It's all
two.
good.
This is
Or your measurement's just a tiny bit
That's
off,
as
like
long as
half an
you're-
inch. You're good.
Wait,
That's
what is
slope.
that?
So,
AB?
let's go to the.
Delete that
Let's
AB.
go to the 6.
Wait, I don't get it. What do you mean AB is the slope?
No, because we did the rise here over the run with this.
Like that?
Here. And then what David was trying to tell us is that AB was 36 and a half. Ooh.
Oh.
What did we do?
I don't know.
I'm evil.
Evil toucher.
Can't do multiple things at the same. So you said 36 and a half.
36 and a half.
Wait, are we just trying to find which one's higher, A or B?
What if, and then convert it to centimeters?
I'm just putting down data.
Okay, so let's do this. Now we're doing B, right? Okay,
Can you
so now I have
convert
to
that to
find the distance
centimeters?
of B. First,
David has to not touch my screen.
Who?
Don't
I'm
touch
finding-
the screen.
It is magnetic. I never ever did this.
92.7.
Which side here? Got it. I'm holding this like a. It sticks to the chair. It's a magnet. It sticks to everything. And
Because it's a magnet.
no dip.
So we have AC. We have AB. We could figure out BC now.
Ah, we could. If we wanted, but.
If we wanted. But we don't want it.
yep.
Oh, what's 138 minus 36?
Okay, wait.
102.
Mr. Hudson, right there.
Oh, wait, Mr. Hudson.
Mr.
My,
Hudson,
Mr. Hudson,
wait,
my
what's-
math teacher back in elementary
wait,
school said mathematicians are lazy.
90.
Efficient, not lazy.
97. Wait, what's
That's not Miss Math.
259.
259.
So wait, what's this point right here?
I'm a slave being held captive. I'm just here.
That's F,
Okay, so
right? We labeled F.
FB is 97 inches.
Do you want to move,
Wanna
like,
go?
do you want to move what you did up here, like, down to the side so we can see both of them? So that might be better.
Okay, now you do the slope of B.
I gotta go convert this because I know you guys are gonna want
Okay,
me
I'm
to.
gonna let go in 5, 4, 3, 2, 1.
No, yeah.
Careful
So
the mirrors.
wait, what's the rise again?
Wait,
Let go of it.
246. 4.
Okay, the rise is 31.
Okay.
So 31 divided by 97.
No,
Okay, so the slope.
Oh my
So the
god.
slope of
You really do
wait,
make
what's this point? What's the slope of LB is 0.32.
So your two slopes are 0.51 and 0.32.
No.
It'll be hilarious.
So we think that A will be bigger because it has a bigger slope.
Well, that's all well and good, but you gotta tell me where.
Oh, we have to find the exact.
Yeah, you got where's TA and where's TB?
All of this
8
information-
minutes.
Wait, all of this information just to try and figure out where a laser hits the wall.
Okay, wait. What's A?
Can't
So
turn on the
decide again.
laser.
What's A? What's AC?
Will you
again?
turn on the laser and then we can
AC
see?
Oh, I will.
Okay, wait. I can do this.
David.
Grab a seat. You got too much of a crowd at the board. Grab a seat.
I can do this.
We ain't gonna stay.
You're on the right path. Just grab a seat.
What's the slope?
I like math class.
What's the slope of AB?
I love what you're doing. Grab a seat. We got 5-ish minutes to wrap.
I like the.
Can you slow down?
So, I love everything you guys did. Amazing exploration. Good measurement acquisition. This is what I'm talking about with trying to structure this different than, if you guys went over to the high school and just had the regular Math 2 class. there's one thing, and I actually went back to Mr. Flynn and said what they don't realize is, now, everything you're doing is right, but you're trying too hard.
I figured out the height for
TA or TB?
TA.
TA? What do you think it is?
70.635.
Are you doing inches or centimeters?
Inches.
He gets a piece of candy.
So, well, we got to see if it's accurate. So you're saying TA is going to be how high?
70.635.
And that's inches?
Yeah. Okay, now I can do TB. Wait, 0.5. Wait, what's what's the slope of B?
That's exactly what I was about to go back to and discuss. The slope. The fact that you guys were finding the slope, I found very interesting, but it's absolutely like poignant. It is on the exact right path that you should be on. I just disagree with the decimal representation.
Wait, what? Oh, do you
What is slope?
It's the ratio.
It's rise over run.
Instead of a decimal?
Right, so our slope, if it's rise over run, who stole the pen?
Oopsie.
Rise over run, right? Our rise was LF, and our run was FA. Right, LF and FA. So if I look at rise and run, I have, or do you want to do inches or metric?
I think this video is a lot of you.
Wait. How old are calculations in inches?
Well, we also have them in metric.
Metric.
Metric is better. I was hoping you guys would vote that way.
Oh, we're just centimeters.
So LF, this is our rise, right? And this is our run, and that's, so 79 over 153.
You got the calculator.
Oh, wait, it's
So-
centimeters divided cancel out, right?
That, yeah, so that's just a ratio, right? Centimeter over centimeter. That's our height over our length, right? Or base, I guess we could call it, because we're used to base being the bottom.
Can we do the laser now?
Okay, guess
So,
what? Yang.
wait,
I just want to do laser.
what other part of this did we know?
The distance from A to
The distance from A to C,
yeah.
right? A to C was 350, almost 2.
Yeah. And
Conversion. Divided by 1.
very smart.
It's 2.3.
Smart boy.
So then we multiply the height by 2.3.
Yeah. Okay.
So it's 181. Yeah.
Okay.
Isn't that the same as
181 centimeters.
Wait, so we're already
That's where
right
it
with
was the
TA.
wall.
Was TA right too then?
181 centimeters is
About.
this tall, right where this point is.
So,
They're right
yeah,
about as
height.
tall as I am,
I
right?
think that's right.
Let's test this.
Is it 70.6 though? Is 7.6?
Wait, can I do the laser? No.
No.
I don't
Can
trust
we
you.
trust you?
No, she's shining my eye for revenge.
No, it's attached.
Oh, never mind.
Yeah.
So pick it
No
up.
offense, but that's tape.
Okay, you gotta push down the laser and move it till it gets to the point that we want.
Wait, me too. It's
Oh,
happening.
it is.
It's happening.
Cool.
Does that look to be about
It's about.
the same height as me?
Well, you can go stand
No,
over
no,
there.
fine. Remember to the middle. Yeah. Go.
Yeah. Well, don't shine it in my eyes.
Go down.
You can cover
So
your
that
eye.
181, right? It was like right about this.
Yeah.
Oh, wow.
Now wait a minute.
Close enough.
Let's, on our paper, set this up for the other triangle real quick that we found. So same height, right? Still the 79. Before we shine the laser.
Then it's 92.7. Wait.
How'd you get the
Oh,
92 point?
Should I write
Eight.
this down on my face?
Yeah, it's more about just understanding what we're doing.
Okay.
I'm not that worried about you having all this written
Oh
down.
wait, it's FB. It's FB.
I'm not writing none of it.
Yeah, we want FB over here, right? So our FA,
So if we know the
FB was
distance between A and B, we just add it on to A.
246, right?
Yeah.
What?
What are we then going to put down here? If we just used this,
Then we would do
FC.
BC, right?
Yeah.
This other distance right here is going to be our similar triangle.
So that
Do we
means
think that-
250 now.
Yeah, 259.
So it'd be a little bit higher, but not by much.
Ooh, it's going to be a little bit higher, but not by much. What's this? Conversion factor.
It's 1.05.
So do that to
Keep that in your calculator. Just hit times
Okay, and then
79.
83.17.
Just pay.
Tiny
Quick
bit
shine the
taller.
laser someone.
Me.
Buckley.
Hey.
Said someone. You never said I'm gonna shine the laser.
83 is right here.
Okay. So
Now, why can't it get as high as 83?
Because it doesn't have it's the angle, the hinge thing.
What?
This
It's
is
shorter.
bumping out our
Yeah, that.
distance.
That too.
If we take away that distance, this is
Are we gonna do a big
33.
Are we gonna get like the leg and the hind, or like the legs, and like the face and do all that stuff?
We don't need to. Remember what our mission
Oh
was.
yeah.
Our task at hand was find where the terminating points are. Did we
Yeah.
find the terminating
Yeah.
points? There we go. So, real quick, grab a seat. And we're not going to get out here early today. My apologies, but we'll get out here on time.
On time.
The lesson that we essentially didn't do, and we will go back to tomorrow and take questions if we need. But that lesson was just dealing with our similar triangles, going further with this. So the question of determine if these triangles are something, this is lame, right? I decided we would take the more fun way through this. But what you set up with that slope that you didn't realize was just the similarity ratios. Your rise and your run, when you said the slope is going to be the same, well, not technically if we graphed it all, because it would be the inverse, right?
Yeah.
But what you were talking about was if I reflect my triangle, the slope will be the same, right? That rise and that run, that was just the similarity ratio of corresponding parts.
Oh.
Remember the CP-CTC?
Yeah.
So corresponding parts. Right. So tomorrow, where we'll extend this, just to let you guys know, is problems like this where we need to find TN, right? Missing pieces of similarity situations. All right, we're out of here. Have a great day, guys. Thank you for your exploration.